Yeah, so I introduced me already. I'm Dalius, and I wanted to start the presentation by picking a random person from the stage and inviting from here, and inviting them here. So, no, I'm joking, but I wanted you to feel the stress. So. All right. Oh yeah. So I'm gonna read the first few slides from my notes, if you don't mind, because that will help me get started. Yeah. So thank you for everyone who came here. I hope my talk is gonna be interesting for you. So today I'm gonna talk about randomly generated content and more specifically maps. We're gonna discuss some popular approaches that we found when going into research when trying to implement maps for our game, and then go into a specific example of how we specifically did for Treasure Tile. Just a quick show of hands, who tried our game yesterday? Okay. All right. So our game is basically a simplified RPG. What makes this a bit easier for us is that it's tile-based. So like generating actual terrain would be a bit more complicated. However, the techniques that I'm gonna talk about today are also transferable to that. And the game itself it has all the RPG elements you want, like the skills, items, different characters, quests, narrative, and all the sorts of that. I have some nice cards here at the end if you want to pick and check our game. We have a demo on Steam. A little bit about me. My passion is making games. Been playing with that since childhood, and now have a few years up my sleeve in working professionally. I'm the only programmer at the moment at Golem House that made the Treasure Tile, and my couple of my favorite games somehow also ended up including randomly generated maps like XCOM and Diablo. So to kick off, first I wanted to ask the question: when would you want to use randomly generated maps? And the main point I want to stress out is it really depends on the design of your game, because I feel like often people think that randomly generated content is free content, and especially young indie developers, but it's really not. And there's a reason why big studios as well don't necessarily just end up randomly producing content, because they also have talent for that, but for some reason they don't do it. And one explanation that I could find is like even a bad level designer will be able to make something that looks okay, that is really hard to replicate systematically. So if you're if for example you don't really count on people replaying your maps, or you don't really have any dynamic content that changes on the map, or at least you don't need that benefit from the randomly generated content, then maybe just handcrafting the maps might end up being better, because with handcrafting you kind of upfront you know how much time you're going to have to spend on doing the map. But when you start doing procedural maps, the work is beyond the horizon. So you don't. It might feel that you're going to generate maps and they're going to look great, but actually at each step you have issues or problems how to make something look really handcrafted, or or in other words organic. Yeah, so first I would really invite to think about whether the the design of your game really would benefit from random maps or not, and yeah, not to go into it thinking that it's free content. Basically, my point with the slide. For us, we decided from the beginning that we want to do random maps, and because it's also a tile-based game, so it kind of felt fairly natural to do that. But we had some problems to figure out, or some questions to answer before that. One of the things that we wanted was for the maps to be open area, but if you went into looking for random map generation algorithms, a lot of them focus on dungeons. So we had to kind of stitch together some things to make it open world. But apparently, generating dungeons and generating open areas is not that different, as you'll see later. Another thing that we wanted from this system was for designers and the artists to easily be able to create new maps and with different variety of terrain, because back then I was also the only programmer, and I would have to do some other things, while preferably the artist and the designer should be able to have a vision of what kind of terrain they want or what kind of map they want, and to be able to create that easily. So that was a big focus for us. Is the extension with new content. That's one of the benefits that we took from generating maps, because we have some content that changes depending on basically random events that happen in the map, and otherwise, if it was a static map, it might be more complicated to like leave empty areas or stuff like that, and that doesn't always look great. One of the problems we had was fitting everything into the map, because the tiles in our game are fairly big, but you still want to have a lot of content to add a lot of content in there. Of course, we tried to make it look as natural, or at least to not make it glaringly obvious that it wasn't handmade. So like, no, we try to avoid straight lines and stuff like that. If to go into a bit more detail what I mean by organic, maybe I should have started with that, but yeah. So that was our basic problem definition. So we started with going into research, and there's a huge variety of approaches in generating maps, and so I'm gonna go into a few popular games and just quickly talk about what they are. Oh, sorry. So first, Path of Exile. So as I noticed in a lot of big games, they use a combination of a person designing, in this example, a person designing the layout of the map, and then the algorithm generating all the tiles and stitching together, and all the like extra rooms or extra corridors that don't really matter that much. So that, for example, here, if you're if the layout has to be the same every time, but you still want the map to be different or to look different every time, it might be an approach good for you. In Diablo, on the other hand, when we're talking about dungeons, there the different layout is the point. So what is handcrafted here is basically segments of the dungeons, and the dungeons end up stitched together. So they might end up looking fairly repetitive, but that isn't really the point of going into the dungeon. The point is so that the player doesn't know the layout. So they could go and farm the dungeons, but each time, even though some segments are repetitive, it's not that boring, basically. XCOM as well. Not very important for this talk, but still wanted to mention it was for me an interesting find. So what they do is they have these bases for each map, and I don't know who tried XCOM, but it's basically a turn-based tactical game where the layout of your units really matter. So like if you're facing an enemy up front, you have a much higher chance of dealing damage to them instead of like if they're behind a cover. So everything here could be used as a cover. So their layout basically stays the same for this map, for example, but they will generate different maps by placing different buildings into these slots. And even though that doesn't sound like that much of a change, different buildings still provide different opportunities of you to strategize how you're going to approach enemies and stuff like that. One notable example, anyone who's worked with games probably already maybe used some of that, are map editors, and they also use this kind of combined approach of some random generation tools. For example, if you want to add greenery or forests, you don't want to go and place every tree by hand and scale it and rotate it. It would be insane. So you just have a brush, and that basically does all of that for you. So you just do the layout of it. Yeah. So now going into our case, we have a basic structure of how it works from top to bottom. And so first we decide what kind of rooms we want the map to contain. And room comes from the dungeon generation algorithm, so we still call it rooms. But that's basically, you translate room to an open area in the map, and that's voila, that's your trick, basically. And then we generate the model for the map, so we place all the rooms in the map that it has to contain. We carve paths between those rooms, and then at the end we create a presentation, representation of that model where the player actually plays. So starting with rooms, we have some variety of them. So they can be enemies, for example, groups of enemies, and they also could be different tiers of enemies. They can be map events, like in this case I think it's a shrine where when you come close to it and interact with it, a wall appears around you and you can't leave until you defeat all the enemies that it spawns, or chests. Other varieties include like waypoints and quest locations. That was one of the things that was really important for us, that you can go into a map and that map can have three quests, and you will have only one quest at a time, and otherwise you might need like a specific room for it. And then what you have a map with 3 rooms that are either empty or populated just by normal enemies. And I remember that in I think in Diablo 2 there was cases where like you enter this area and it looks like something should be happening here, but it isn't. And I don't know, maybe that for me it was an experience that took me out of the game, but maybe you don't share the same. Anyway, but that was one of the benefits that we used, is like if you have this quest, now when you enter this biome or this map, this room will be added into it. So talking about rooms, and I promise that's the only slide that has code. I tried to keep it focused on images. So we start off with prioritizing rooms, because this is the problem of fitting everything. And some rooms have a higher priority than others. So for example, all maps should have exits. And if a waypoint is provided for that map, it should definitely always have it. So that's why it's like up the priority stack. Then quests, they definitely, of course, also have to fit. And because these ones are, they take the least amount of space, and every map will fit them. And this is where the enemy tiers start being generated, where they really start taking up the space. So they are at the bottom of the stack. And this is just an example of we made like how to say, a system where you can extend this interface, create a room processor, and add it into the pipeline, and you can add any kind of new type of room, which yeah, helps makes it easy and came in really handy during development. So we define a room stack, we collect all the rooms, and we go into generating the model. And we start by so when we're generating, we generally have a size that varies between each map, and we first need to fit the rooms basically into the map. And so you saw the room priority stack before, and how the implementation works basically is what that does is it creates layers of the grid. So for each stack it will create a layer, and then at the end they are pressed down together basically to create the one model. And all the rooms that are overlapping too much and they are of a lower priority are going to end up being removed. But what matters here is how you place the rooms in the map. And because the rooms are circular shaped, that's why the example looks like this. But there are a few ways to do that. One is naively just randomly place them. But the problem with that is you're not going to optimally fill the whole map. And there's a smart way, I think it's called circle packing in a square. It's like a mathematical problem. Which gets even more complicated because we don't know the sizes of the rooms up front because of how we select enemies and the rooms could be of different sizes, so it becomes like an online problem that it's really complex. But what we found that actually naively just placing rooms is good enough. So we went with that. Right. So after we place the rooms, place all the layers, and we collapse them together into one map, we go into creating connections between those rooms. So here, all the I'll use the laser. This is basically a room. Yeah, that's all you need to know, I think. So that's the whole map. This is a small enemy room in this case. Talking about settings, easy settings for the designers or for the artists. I wanted to make like a slider from 0 to 1 to be able to say like the connectivity of this map is going to be like the minimum and the maximum. I didn't want them to have to like add the number of connections that it has. Also, it became a problem of figure out how the rooms should actually be connected. So I decided to find a few ways of how to create the minimum connectivity and the maximum, so that you can use a slider basically between those two and vary the density of the connections in this map. So for the maximum, what I tried is the Delanoy triangulation, and it has some really nice properties, because otherwise what you could do is just create a connection between every room. But then if you start randomly removing the connections, it doesn't look that great, and like a room here could be connected to a room to this one, and it doesn't look great. So what this algorithm has some really nice properties. What it does is connects rooms with the basically only the closest ones, and another property that it has that the paths never cross. And to me it seemed like this looks fairly like a natural connection basically between these rooms. So that's how we decided on the maximum connectivity, and for the minimum it's a fairly known graph problem. It's called minimum spanning tree. So with this we find the minimum connection, and then we can just vary the connectivity. Right. So before going into the next step, I want to talk briefly about noise. So noise is used extensively in basically every step of the way, generating these maps, in our case. And of course there's the white noise, generally known from TV. And a couple very notable examples are the Worley, or otherwise called, I think, like Voronoi noise, or Voronoi diagrams should be familiar to you, and Perlin. And in our case, we went with Perlin noise. But thing is, like, if you have a good system, you can exchange these noises or with others and try, because it what's great is that it has these properties that you can just use for free, because otherwise there's some things that would require a lot of work to implement, and here you get those properties for free, and I'm gonna go into detail of what that is. And so in the next step, after we decided how densely connected the map should be, is actually carving the paths between those rooms that we decide. And of course, immediate solution would be to just create straight lines between those rooms, but we're trying to create something that looks natural. So what we went with was using a virtual terrain, in this case Perlin noise, and running a star through that. So basically, yeah, you have a connection from here to here. So the A star tries to find it, and it goes like around these virtual obstacles to find. And because Perlin noise has this kind of organic structure, the connections look much better than it was like if it was a straight line. And it would already be like a dungeon, I would say. But of course, we want to make it look even nicer, and to have more options of how to change the look of the map. So how we try to do it to make it look more natural. First step was we want to add noise again at the top, basically just to make it a bit more fuzzy, because people are or human brain is very good at recognizing patterns, and even though this is already randomized, I think if you played it, you would still start seeing that something, I mean, the connection width is always the same, or like if these rooms are connected, there's like, yeah, basically patterns. I thought you would notice. So one thing what I added on the top is noise. And after you add noise, of course, you need to clean it. One of the approaches that I found from image processing was this open and close, or just applying erode and dilate things in different orders. So I think that would be a great way to do it. But I wanted to go a step further, and one of the things that I found when researching of how maps were made was cellular automatons. And I don't know if you're familiar with that, but basically Conway's Game of Life, you must have heard about it, is a cellular automaton. It is just cells that have really basic rules of like how many cells do you need as your neighbors for a new cell to create or for you to die. And that algorithm, that simple algorithm by itself, is used to create dungeons, basically. I mean, this needs some cleaning up, but it basically already has like a pretty organic shape, and it looks cool. So I thought that this may be a good use for the cleaning step, because you also get this nice property of it gets cleaned up, but also tries to maintain some kind of organic shape. And I know you can't see that much difference here, but yeah. A few things I want to point out. So like the shapes become slightly more rounded, and you end up adding like random how to say, appendages to these paths. Another thing, another property that comes out of this is that if so in this case there's we didn't fill this spot in, but if you change the rules of the cellular automaton, if you run fewer or more iterations of it, you might connect all of these rooms together, which as well, I think maybe if you created a map and you added 3 groups of enemy close to each other, you would probably think, maybe I should create one area around that. So I think it captures some of thought processes that would go when you would try to create it by hand. Basically, that would be the generating of the model. And here I have some examples of how just using those steps you can create different different looking areas. And this is basically changing the path size. I added sometimes the dilate step by itself. You change the noise density and scale, or change how the cleanup process works. And and you're able to create I would say fairly different characters for the map. Right, so after we create the model, we need to go into the presentation of that. And the stack for creating the presentation is, first we need to decide on the terrain, how it's going to look, because the model that you saw before, that's basically the area where the player is going to be able to walk the green part, and everything around that is just going to be some impassable areas that are going to be basically filled with terrain. Then we need of course apply textures and clusters. I'm going to talk about that in a few slides. And of course on the top we add the decorations to create the final basically feel for, or the character for the map. So terrain height maps, I don't know how familiar you are with that, but basically you can use almost even a grayscale picture of something and just convert pixels to height. Like a brighter pixel could mean a higher elevation in that position of the map. And these are some ways of generating height maps that I found, but we're gonna go along with Perlin noise again. One thing that is fairly interesting is that if you use the same, for example, noise texture for the A-star carving of the paths, and then you use that for terrain, you can create maps where, for example, you have a canyon or like a road, and use the so basically the canyon would be carved where there's the lower value of the Perlin noise, and the higher values then end up being around it. So you can, out of that, you just by using the same texture, you can get the elevation going into the path just for free, just because you use the same texture. Anyway, so we decided to go with Perlin noise, but with Perlin noise, what we did before, we could change the scale and the I think the scale, and it was like random offsets. But anyway, we wanted to add a transformation function to the Perlin noise, because you can then control what you get out of it. And this is an example of a simple Perlin noise, and I use the animation curves just to be able to handcraft a function for that. And this is just how would the normal function would be. So a 0.5 value on the Perlin texture would be equal 0.5, because it would be evaluated on this curve. And using that simple Perlin texture, we can create a map like this. Just to visualize, so this green area was generated in the model, and that basically stays of the same height. So we only worry about this. So simply by just taking Perlin noise, we already get something that looks fairly natural, say. But then we can use the transformation function to start basically modifying it to fit our needs better. For example, in this case, I maybe want the peaks to appear to be flat, basically, and that would represent that the flattening of the peak. And when looking at this, I would invite to imagine that everything that is bright is high, and everything that is dark is low elevation. Or you might want to just skip the transition totally, and then you might get by using that you can get a map looking like this. Or you can go crazy And in this, for example, in this case, you probably don't get much from the scale, but maybe if you scale down, maybe you could have a use for that. For example, here, it's yeah, no, it starts looking quite artistic, but it doesn't look that great, I think, on the map, but it does create some kind of character, and you could even go in. I think this technique is fairly familiar to people working with shaders, for example, and they extensively use noise as well. And this is just another transformation where you take two textures and multiply them together. So for both of them, you apply the curve transformation, and then in the end, you can get some kind of result. But there are also problems with this kind of approach. For me, maybe it's okay if I imagine some kind of terrain to be able to translate it into a picture like this. It's okay because I had to play around with it a lot. But for artists, for example, it's not that easily understandable. So and even though it's quite powerful, just with a few simple transformations, you can get very, very different results. This also means that there's a huge variety of things you can generate, and it might be problematic of you trying to imagine a specific terrain and then getting that out. So with this, what I would really recommend is that write tools that would allow you to generate these very quickly and to get a feel of how this works. And I learned that basically while making this presentation, because what I saw is that artists they haven't caught how to do this, and that's quite problematic, because that was one of the things that we tried to solve, how to make this easy, but apparently it wasn't. Anyway, but if you play around with it, you really get the hang of it. So after we decided on the terrain, on the height map, we need to texture it. So it's fairly simple. So we just choose random textures for the tiles. But here I'm going to introduce clusters as well. And one of the things that I think makes a map look more natural is that there are meta structures. There are big structures. So when you're laying out a map, you don't just place random assets. You think of some kind of order to them. And how we try to apply that in applying textures is to just basically create clusters. So for example, if you have mushrooms growing, they usually grow in bunches, not one by one. And so you can create a basically cluster from that. Here again, where Perlin noise comes in really handy, because you can create an algorithm to generate a shape like this, but or you can just use Perlin noise and just threshold it, and then you get a nice organic shape, and just use that to place the tiles. That doesn't necessarily work always. Like you can see here, it doesn't really work with tiles that should fit into a specific edge, but you can create tiles that they don't conform to this rule, and it looks okay, in my opinion. And it adds a feeling of somebody deciding on some kind of order and laying it there. Then we add decorations. That's where I think the artists have the most fun, just to add all sorts of decorations, like I don't know, like trees and greenery and sometimes even very creative things. And we top it all off with environment effects. For example, so the maps, after we generate them, the maps are fairly static. We don't have moving decorations or stuff like that. So just by adding a simple fog makes it look a lot better, a lot more dynamic. And the fog can be also used to accentuate heights. For example, what I saw is that artists started using the decorations quite creatively, so they started creating terrain objects like rocks or even sand dunes, or creating god rays, because the decorations in our game are sprites. It's like a 2.5D game. And then, of course, at the top you had some lighting and effects. In this case, we have like a slight fisheye effect added. Of course, shadows, some vignette effect. Just to make it look more pretty, because I think that looks a bit more boring than the one on the right. And so some varieties that we managed to create with these. One, so in this example we have a shoreline, so we just basically split the map in half and we create a, oh, I should not have pressed that, okay. What else can I say about this map? Looks good. My favorite one, because I think I wanted to showcase the things that you can do up until the point at how we where we stopped developing the generation algorithm. So here you have a mountain slope. You use the fog to accentuate height, and you can't see it from here, but like if you come closer to the edge, you kind of can see behind the fog that there are decorations on at the bottom, but it creates this sense of height. One notable thing is this, I would call it metastructure of the map. In this case, it was a simple graph as well, just to show how the height of the map is changing as we go from left to right. But here, there is an option to, for example, use a texture, say, and use that texture as like a metastructure. So before, when we generated the height map and we and we created tiles from that, it was basically on a flat surface. But you can make that surface not flat. And one case, and how you could make that would be, for example, a simple texture that you add, and then, for example, you place the terrain that you generate not on a flat surface, or not on a flat surface, but, for example, on a canyon that goes like this, and instead of basically instead of placing the terrain on the on a flat surface, you can create random yet with the same metastructure map. We use something like that in this example. We have our world map is an island, and we wanted to keep the shorelines as they appear in the world map. So we use a texture to define the shoreline, and and then we can add this really nice looking effect made by Paulina here. To accentuate the sorry, I need water. To accentuate the shoreline. Of course, you probably don't need to generate all of this, but we try not to optimize prematurely. Or you can just basically avoid the terrain at all and create something like a mountain Mordor corridor thing. We even use that for smaller scale as well. So in this case, it's a boss location, and it's a very simple map. You just place one boss room with one big boss room, and that's it. You get that for free, basically. So some conclusions. And of course, there are concerns. I think we reach a point where the maps look okay, but they could be better. But as I said, it's a fairly big problem in generating maps or trying to reach that handcrafted feel. I showed you maps from a large scale. I don't know how much you can feel, especially those who try the game, from this kind of perspective. I think you can kind of feel that it's that it's not just randomly placed. As well, we have a minimap, but it could maybe not matter that much. But it's a discussion. Optimizations, of course, when the maps get really big, it can start getting quite laggy. But there are ways to improve that. And too many settings, something that I mentioned. So I think one is for the presentation, one is for generating the terrain. And for me, this is fine. but I'm a programmer, and I want to point out that this is not fine for a designer, and this is not fine for an artist. Maybe this density part is understandable enough when it talks about paths, but texture scale, cost multipliers, things like that, it doesn't make sense. And so we really need to think of how to make this more understandable, because the problem is that designers and artists are trying to create the maps, and they are not able to use everything that it actually provides. So they don't. I've showed you like the different characters that you can develop. Well, I mean, like the character of the map, and what I saw happening is that the default settings are just being used. So yeah, so something really needs to be changed there from the implementation side. What we're thinking about adding in the future, more life basically to the map. There should be some kind of, for example, butterflies or birds flying around to just create a bit more dynamic view. Another way would be to slightly animate the decorations. And they can be fairly easily animated since they're just sprites. More meta structures, I think sectors I think would fall into that same category, because something like a small island or a place of ruin really adds the sense that somebody, not necessarily that somebody put thought into this, but that something natural happened here or adds some history to it. One problem that we have with maps is that when you go from one to another, the biomes might change drastically. So what would be nice to add sectors. So let's say what I mean by sectors here, say like that's a greenery biome or sector, and it's like a desert sector. And it would be good to have these kinds of transitions, because you might go from one map to the other and it's like drastically changing. And in sectors, that's where the texture approach would also really work well. Nice to have things that we will probably not have time. Maybe living terrain. By that I mean the terrain tiles could move, or maybe adapt more to the situations, or create scenarios for the player, because it is a tile-based game, and so you kind of almost even expect that to happen when the map is like made of tiles, and in some way systematically create this history for a map, because when you go into the map, it might look natural, but it might not have any narrative behind it. It might look boring. So maybe a main object of the map that gets placed like a pyramid could be. We could create a decorative room. A decorative room processor, and add it into the pipeline, and just add decorative rooms around to add some kind of history. Yeah. Some of the resources. So yeah, cheeky stork, I really recommend looking into these. One notable one is the Herbert Wolverson. If you're making something even remotely resembling our game, I really recommend checking out the talk, because he discusses a lot of techniques, a lot of different approaches. And when creating your map, it's not there isn't one solution that will work for everyone. It really depends on the design of the game, on how it looks, or how you imagine it, you want it to look. So there's a lot of tools there. There's a lot of things like, as they showed, using noise textures, or using a combined approach of a person defining layout or segments or stuff like that. But depends on what you need for your design. And I think these talks at least should give you a start of like a small tool case of things that you can try to use and stitch together for your particular case. We are looking for a programmer as well. So check us out. Again, I have some nice looking cards at the end, so you don't necessarily need to take the picture. And questions. Thank you.
Thank you. Thank you. I'm not such a professional programmer, I would say, but this was quite nice. Thank you for just one slide of code. It actually was understandable. Very nice. So do we have some questions in the room? Nice.
Thank you for the talk. It was very inspiring. Could you please rewind back to the slide where a star algorithm is used, the pathfinding? Could you please explain what exactly happens there? Because once we have the parallel noise and we have a connected graph of the rooms, what happens then? How do you combine the two?
Sorry, when this one, right?
Yeah, like it's a randomly generated parallel noise on the one hand, and the graph of the rooms connected.
Yeah.
And what happens then?
So I would imagine that this is placed on the top of this. I don't think maybe that's not exactly the texture that was being used for carving these paths, but imagine that basically this is placed on top of here. So this room would be here, and you want to connect this room to this room. So from here you run a star, and it assumes that this is a low cost path, and this is a high-cost path, so it will try to avoid the high-cost paths, and it will go around these things, and it will carve a path to that room.
Okay, and if the rooms are placed on the like on the higher places of the terrain, do you carve the terrain, or you just leave them?
So terrain is basically terrain is less prioritized, because the top priority is that the player are able to reach all the rooms, all the necessary rooms are placed, and the terrain is basically just so it looks good. So basically we carve everything out. You could say that we just carve everything out in the terrain, and the terrain is like these spots, these black spots where it gets filled in.
Okay, just find the cheapest path between the dots, right?
Yeah.
Okay.
Yeah.
Thank you.
Any other questions?
Okay, hi. So I wonder, do you generate the world on loading time, and then you just spawn everything at once?
Yeah.
And then do any fancy logic about loading just chunks or something?
Well, we're starting to see the need for that, but also it's not very optimized as well. I think so. Generating the model is fairly quick. It's more about placing the objects and the tile. So when you saw the map, like even from this, it's going to be far away, but all tiles are separate. They're not. It's not a one. You could generate a mesh from that. Maybe that would be faster, but with large maps, we're starting to see the need to add low discrete.
So you have a limit on the size of the map, because the texture cannot be like too big, or
it's not one texture.
Okay, you just
it's not generated yet, but even if you wanted to generate a terrain, you can split it into sectors.
Okay.
Okay.
Hey, thank you for the talk. I was really glad you mentioned wave function collapse in the end in resources, and I was wondering if you thought about using it in your case maybe on some micro scale level when adding some effects to already generated terrain, because it seems quite intuitive for artists to actually like generate this template and then test it out on the level, see if it works for them or not. And have you tried it? Have you thought about it?
Just so to everyone else, you're talking about
Yep.
this one, yeah. To me, it seemed like a very interesting approach, and I haven't tried it out on the map. So that's why I had to like have the all the problems defined, because when I tried to think about using this algorithm, for me it didn't solve the problems that I had of placing everything. It's nice to generate a random map, but we need to place rooms. We need to put specific rooms, and for that it didn't look. I didn't find a way of how to use it. Maybe in the pipeline, in like the cleaning up step, maybe it would come in handy, but I haven't found a use for that yet. For in this case, in my case.
Yeah, I thought, for example, you have a screenshot of some lava field, so it's impassable terrain, and there are just some rocks put in there. And for example, artists can generate some template with some random rocks thrown around, and it generally generates a kind of better looking final results than just placing those, as for example on your screenshot there were repeating tiles here and there, and it was quite noticeable. And I think with the algorithm it kind of produces better results here and there.
I can visualize now what you mean.
On a micro level, like it doesn't work for like the whole level for the rooms, but it works on like some special effects.
Could work with decorations or even texturing the tiles as well. Could maybe work. Yeah. Thank you.
Any other question we have? No.
Hey, thank you for the talk. I'm interested from your the slides that you have. I see that everything's 3D, but your game's like top down. Was there any reason not to go with 2D specifically?
There are 3D elements, so the terrain itself is three-dimensional, and I don't have a picture of that, but for example, when you go into towns are handmade, and they have 3D buildings, and maybe in the future we're also gonna add like two-dimensional structures in there. I guess it could work as 2D as well, but in our case, I don't.
Yeah, maybe if you have like 3D towns, like it's a very similar case with like League of Legends, right? There, they have, at least they used to have. I haven't played in a very long time. They used to have like the map was actually like really flat. They just had like it was drawn to seem like 3D, and that's I imagine that saves like a bunch of vertices as well as if you split, if you say your tiles are separate. A kind of similar issue was with Minecraft. Like one of the biggest things that they did was in optimization sense. They made it to be like not separate cube meshes because that saves like thousands of vertices, if not millions, in the long run. But thank you, anyways.
Yeah, thank you.
Someone got a valuable sign from the audience as well, right? Like switching. Nice. Do we have more questions? All right. Thank you very much for participating in this discussion, and watching the presentation was really nice. Once,
Thank you.
please, one again.
Thank you, everyone.
Right.